I'm going to be talking about optimizing on the web. I've got some specific tips for Godot and Unity, but it's broadly applicable to kind of most of what you're doing. Unreal Engine doesn't build for the web in UE5. They got rid of that, so not so much for Unreal. But I am Dom. I am the web games advocate at Crazy Games, and that is a fancy title to say I am the techie on the business team. So I kind of bridge the business team. So that's kind of outreach to developers, kind of doing SDK integrations and that sort of thing, and partnerships in particular. And I kind of bring all of the technical expertise to that team. So over the last 20 years, I've been making games largely in Unity. I did 10 years professionally using Unity to make apps and games, and then moved on to Crazy Games. And basically, I've used every engine. I actually started with Flash games, so I've been around the web game space for quite a while. I've got quite a fun job because I get to basically make stuff in all of the engines and make stuff work. So I'm talking about the web in particular because it's actually a really exciting space. As an indie developer, you don't really have to put as much resources into your web games. So it doesn't have to be these big 40-hour epic games. You don't need a massive team or a year-long development cycle. Like, you can do smaller games that work well, and that it just kind of de-risks, and you can earn a bit of money from that, and then you can kind of build that over time. There are a few challenges on the web, so it's largely a different audience. So there are a lot of players. Web games tend to be free with ads, but that does mean you get tons and tons of players. On Crazy Games, we have 45 million players that come back every month. And that usually translates into pretty much every launch game seeing 20 to 50,000 players in the launch week. But the problem with that is that you've got to keep them coming back, and that kind of ties into why optimization works really well, or is really important, sorry. But the kind of core things you focus on are playtime and retention, and those numbers both go up when you've got a really fun game. And that, to me, just is really good, because that's the bit that, as a game developer, you want to really focus on. So that's a bit about why web games are great. But the big challenge in web games is getting players into your game. And for this talk, we're going to be focusing on getting your players playing the game as quickly as possible. You need to get players playing fast on the web. Everything you can do to cut down that initial load time is going to really improve the amount of plays you have. So why does it even matter? This is some research Google did a little while ago, but for every second, the bounce rate, so players that see a game and then leave, goes up a lot. So 1 and 2 seconds, kind of around the same ballpark. Then as soon as you start getting beyond 3 seconds of loading time, players are bouncing at really high rates, and you don't want that, because web games are all about numbers. So there's a bit of research that's been done that says basically there are 3 kind of levels of interaction time for the player. So less than 100 milliseconds is kind of seen as instant. So you don't really need to give any feedback. The player feels like the actions they take immediately make an effect on the game or on what they're doing. Under a second, you're still in this state of flow. So the player's not interrupted. You still don't need to do anything, but they have noticed the delay. They're starting to think, okay, something's not happening. It's not instant. And then kind of above that, in the 1 to 10 second range, you really need to put something on the screen. At this point, the player's attention is wandering. They're thinking about other things they can do. They've lost focus on this. If you have something on the screen, whether that's a loading bar, a nice little animation, some text to kind of explain your game, in Skyrim, they have the loading text that gives hints about the game and little background bits of context. All of that sort of thing is really, really important if your load time is kind of greater than a second. And then above 10 seconds, probably a lot of your players have already left. So this is really, really important because you want your players to be playing games. So providing feedback as quickly as possible is the main goal with a web game and optimization in a web game. So actually Google, in that feedback, in that research they did, it was at 5 seconds, 90%, the probability of a player bouncing has increased by 90%. So that's, you need players and you want players to be playing a game. You don't want them to be leaving. So you have to kind of switch your thinking about optimization on web away from runtime performance more into this initial load time. That's where the bulk of your effort should be spent. And your objective isn't to load the full game instantly. It's to get something on the screen that the players can see is happening and kind of move along a little bit with that. So the actual loading process, when a player clicks a link and sees your game, the browser will download the game. That's obvious, I know, but it's worth saying. The bigger your game files, the longer this download's going to take. Once it's downloaded the game, it then executes the JavaScript and WebAssembly files. The engine initializes, it decompresses and loads the assets into memory. Your first game scene loads, and then all of your initialization code runs, and then your first frame's painted. So everything we can do above that first frame paint will dramatically reduce your load times. So what do we actually do about it? So we kind of split it. Oh, that came in backwards. We split it into three parts. So there's the download, which is the kind of bulk of the waiting time. A lot of the time you'll have a progress bar, but that is going to be the big wait time. Initialization is when your players are stood staring at a black screen and nothing's happening before the first frame paints. And then runtime performance is all of your kind of, while the game's running, there are extra things you can do. I'll touch a little bit on that at the end. But so to improve your download speeds, the big thing is loading the initial content first and then kind of loading things in the background. For initialization, you want to look at engine stripping and then your code and what happens in your code in your kind of start and await methods and init and on ready and Godot. The first thing we do is split out the download. So the main way to do that in Unity is through the addressable asset system. Your game assets are all by default included in the main game files. That is like absolutely everything in the game. So your players seeing the tutorial, but the assets for the end game boss, they're all downloaded at the start. In addressables, you can basically split that into addressable groups, and that basically packages each bit up and you can load them separately. So you might have one for level 1 and level 2, and then like that you can package it in different ways, whatever makes sense to you. And the big thing is loading addressable assets is async. So it doesn't actually block the game. So you can run it in the background and still have things animating on the screen. And for the player, that feels really, really good. It holds their attention a bit more, basically. So I assume if you're using Unity, you know what the package manager is. You install addressables through the package manager. Once you've got it installed, it adds this little checkbox to all of your assets that can be made addressable. And that includes folders. So you can package things, like bundle things up in your game assets window in a way where you can just mark the entire folder as addressable, and then that kind of takes care of that. By default, the text input next to the name there will be just the full path of your the asset, but you can change it to something a bit more memorable. So I've done that here. And then you've got groups, and those groups are what packages it all together. So Addressables are a massive subject. I'm not going to have time to run through it all at the minute. Like in this talk, there are a few other resources. I'll send some links and I'll share some links on the screen for some other resources about that. But this is kind of the bulk of it. You mark your assets as addressable, you put them in groups, and then you load it by this text input that's here in the game in the asset window. So you can set up addressable asset groups. So you can have as many of these groups as you want. These are the bundles. So like I said, you might have them split by level. So level 1, level 2. I often do some background music as well. So while the player's in the menu or the tutorial or whatever, there's some extra music that I load first. And as soon as that's loaded, you can kind of immediately use it. So that's really useful. You can use labels to organize them as well. So using a label, you could start downloads on multiple groups at once. And then once you've marked them, all of the assets that you want to use as addressables as addressable in Unity, and you've assigned your groups, set up your labels, then there's this build option here. The default build script is the one that I just always use. It's really easy. Unity just has that packaged in. That will build everything to a specific folder. Again, I don't really have a huge amount of time to explain this in detail, but that builds it into a separate folder. You can put that in streaming assets, and Unity will load that in. And you can, it's a very simple bit of code. It's quite similar to the resources folder. So resources.load, you actually just have addressables, load scene async and load asset async. And these are tasks as well. So you can do it asynchronously. You can show progress bars, all of that good stuff. And you just load it by that string name, the string path. Like I said, I could do an entire talk on addressables. This is just to kind of get you into the mindset of, okay, I need to split out each part of the game and load them separately. There is a lot to learn with this. It's a big system. It's a cool system. It does some really great things. You can host things externally. You can update content on the fly. It's all included in addressables. I recommend you use the Unity Learn course. That's what's linked here. That's what's in the QR code, and that'll kind of get you up and running. And then for Godot, it's a little bit more involved. The steps are broadly the same, but there isn't a specific single system that does it all. So again, all game assets are packaged into the main PCK bundle. You can split that out into separate PCK bundles. That's similar to the addressable groups in Unity. You basically combine these by stuff that is used together. So you can load one chunk of things and have it run and have it download, and then you can use it immediately. And then you can asynchronously load your PCKs with resource interactive loader, and that won't stop block execution. It won't freeze the game. So again, async stuff is good on the web. So there are 3 main steps to the Godot resource system. You export as separate PCKs. You then have to manually download and manually mount that to the file system, and then you can load it. So it's a little bit more involved, but it still achieves the same goals. So the first thing you'll do is create a new preset in your export templates. You'll just choose the specific files you want to use. So you can change the export mode to selected resources and dependencies, and then you select which one you want, and then export the PCK, and that will bundle it all up. Then you can host that somewhere yourself. Godot doesn't really have anything similar to streaming assets, so generally you'll be hosting this on your own server. You first have to download it. So if you're using Godot and you're making a web game, you probably know how to download things, but I've included some code here just to illustrate. Once you've downloaded it, you then have to write that to the user's file system, which is an extra step that you wouldn't necessarily have to think about, but you do have to write it to the file system so Godot can then load it in. And then after that, you use the resource interactive loader to load it in. Because if you don't do that, the Godot is going to load your entire bundle in the same frame. It's going to cause the whole game to freeze. You might get a black screen. The game will just pause, whatever. That's not good for a player. They don't tend to like things just freezing. Then the next thing to bring down your build sizes, hopefully using splitting out your assets into different downloads or addressable groups. Hopefully that's saved a really big chunk for your initial download. But the next thing you do is compress things with Blockly compression. Blockly tends to be the best. Generally, you get a 15 to 30% reduction in build sizes compared to uncompressed. In Unity, it's just a check mark. It's just a drop-down field. In Godot, again, it's a little bit more involved, but generally, Blockly compression is the one you want to aim for. It's a really good standard, and you get really good compression, and the browser handles it. In Godot, like I said, it's a bit more involved, but it is possible. Once you've exported your HTML build, you can just use the Blockly in the command line. On Windows, I usually just go through Git. On Unix, it tends to be included in the terminal, so it's already there. So you can just Blockly your build, WASM, and PCK files, and then in the export settings, you also want to uncheck embed PCK so that basically your game assets stay external and you can compress them as well. So that's Blockly compression is good, 15 to 30% reduction in build size. Generally, these two steps combined can take a Unity or Godot game from over 50 megabytes to under 10, which is broadly where I would aim for, is 10 megabytes on your initial build size. Then once you've done that, there are also some just quick fire settings to change. So in Unity, you can override the compression for web and use the ASTC block compression. It's really, really efficient. It will really crunch down your file sizes. It does trade a bit of quality, but there are certain levels. So 8x8 block is smaller but lower quality than 4x4 block. You'll need to fiddle with that, see what makes the most impact, see how much you can reduce the quality without it making a noticeable impact in your game, because obviously when you compress things have lower quality. But it is really, really important to compress all of this stuff so you can get your build sizes down as low as possible. For audio, you can force it to mono where possible. Players don't tend to mind where their sound effects are coming from, or if the music has stereo effects. And you want to load in background for all big tracks, because that'll, if you don't have that enabled, that will kind of take a second on startup to load that into memory. And then 3D models, there is vertex compression that you can enable. Again, you can play with how aggressively it compresses them. And then you also want to disable read and write on your 3D models. Unless you're actually using that API, this just adds a bit in memory, and it's better to keep it off, basically. There is this setting alone, the Show Unity logo and splash screen. That setting alone saves a megabyte in your final build size. It's a really big texture. I'm not entirely sure why they include it by default now, because in Unity 6 Plus you don't need a Pro license to hide the splash screen. There are issues on some versions of Unity where if you just disable Show Splash Screen, this texture is still included in your build. So enable Show Splash Screen, disable show Unity logo, and then disable show splash screen again. That will remove it from the build properly. This is something I fought with for quite a while, but Unity has a build report and project auditor package that will help you figure out where issues are. And then if you're uploading to Crazy Games, we have an optimizer, and within our SDK, that will highlight potential issues and let you apply fixes as well. So we've got some good systems in place for Unity. And in Godot, there are fewer settings to fiddle around with in Godot for this sort of thing. You don't get as much. You have to do it all a bit more manually, but the broad principles apply. Compress your textures, compress your models, use single channel audio, that sort of thing. I don't know if you've ever published a Unity web game, but you'll see this screen for sometimes 5 seconds, and for a player that is really frustrating. That's the next kind of step in the process. So once you've actually built it, exported it, the user's downloaded it, you then sit on this screen for sometimes up to 5 seconds. This is the step. Well, I'm just going to go back a second. This is the step where Unity, Godot, whatever engine you're using, kind of initializes everything. It starts to run all your code. This is the step between I've started executing and I'm painting the first frame. So the bulk of that is going to be engine initialization. So there are things you can do to strip the modules that are included in the engine. So in Unity, it's very simple. There is a strip engine code checkmark. You can check that, and you can set the manage stripping level to high. You'll want to play around with this. Sometimes that can get too aggressive, strip out code that's needed. If you're using a dependency injection framework, that they can sometimes struggle, but there's something called a link.xml file. You can specify assemblies and classes that won't be stripped during code stripping. Again, a bit too off topic for the talk, but it's something you can do. It's something that's good to be aware of. Not everybody uses DI frameworks, so it's not super relevant. But if you're finding that you've set your stripping level high and all of your code's gone, this can be why, and this can help. In Godot, it's again a lot more of an involved process. You have to build a custom export template. Godot have some documentation on how to do that. I can't go into it now. I just don't have the time. But this can save 10 megabytes in your initial download. It can save a couple of seconds on your on that grey screen. So it's really important to know, to be aware of. They make it a little bit more helpful because they've got this engine compilation configuration editor. It's a mouthful. I'm impressed that I managed to get that out first time. But this will let you figure out what modules you need to include. Without this, it was an absolute nightmare to actually go through and try and figure out what's being used and what's not. But you have this detect from project button here that will scan your project. It'll see everything that's using each of the different modules, and it'll give you some suggestions for what to enable and disable. That's a much more complicated process, but it really is worth doing. It can save a lot in your startup time. And now we come to runtime performance, and I'm aware that this is quite far into the talk. I'm going to do some quick fire general tips because this is less important, but browser games are still they're largely CPU bound. So there are some things to be aware of. So the main thing you'll want to be doing is taking things out of update loops, running things asynchronously where possible, like Unity has tasks, Godot has async await. If you're doing things every frame, that will slow things down. And generally, the crux of optimization is just do fewer things. This kind of applies to the initialization step as well. So when the game first runs, all of your code that happens in start, awake, anything that's loaded into singletons when the game first starts in Godot, it's your preload objects, auto load objects. That's the word I'm looking for. All of that sort of thing that happens at the start that can increase that startup time. So do fewer things is the main thing to say here. So sorry, lost my train of thought for a second there. In general, on the web, you're CPU bound, so you want to keep the your actual game code as light as possible. There are a few things you can do. General best practicing, pool your entities. So if you're instantiating and destroying, or in Godot, you are creating and freeing. If you're doing that multiple times a frame, that can generally hurt performance. So what you tend to do is load them all, not necessarily at the start of the game because you want the startup time to be quicker, but you can kind of load them all in one bucket towards the start of the game, and then enable and disable objects as you go. You want to reduce your allocations wherever possible. And garbage collection's a weird thing in the browser. It's inconsistent and unpredictable, and it's really frustrating to work with sometimes. My general rule of thumb is I'm not ever going to allocate something in update, or I can't remember what the analogy is in Godot. My brain has just completely frozen. But basically, every frame, I'm not doing any allocations, because the garbage collector can just run and cause a stutter. And even if that stutter is only a couple of milliseconds, players notice, and it can really impact how it works and how they feel about the game. The physics of your game generally, also, if you can reduce the physics time step, so the fixed time step in Unity and the physics step in Godot, if you can reduce that to 30 FPS, that'll do wonders as well. You really are CPU bound on the browser. I actually think I've talked really, really quickly, and I'm way ahead of schedule, but I'm going to talk a little bit about the future now. So WebGPU is coming. WebGPU is an evolution of WebGL. You get much better access to the GPU from within the browser. So you can do big 3D games like this. On Crazy Games, we've got a couple that are already working. And I think we were the first commercial platform to have web games running and making web GPU games running and making money. But this is a really big thing for performance, because being so CPU bound, it's good to offload stuff to the GPU where possible. So in WebGPU, you can actually use compute shaders. I use compute shaders for I use compute shaders to run thousands of bullets in the browser. So I got 120,000 bullets on my bullet hell game running at 60 FPS in the browser, which was only possible in WebGPU. And that is everything that I have to talk about. I talked really quickly. There's a lot to go through. So actually, it's probably good to have a bit of a longer time for questions. So if anybody has any questions, do let me know. So I'm gonna wrap up there a little bit early.
Hi Dom, thank you for a great presentation there. Lots of good stuff going on in there.
Yeah, a lot to run through.
Yeah, very much so. Just as a reminder to everyone, if they have any questions, please put them in the chat. We've got a bunch of questions for Dom already, but we'd love to hear any more that you've got going on there. The first one I'd like to ask though, because you just mentioned WebGPU there.
Yep.
How does all of this, the games in the game engines in the browser, how is it that they actually work? Where does WebGPU come into it? Is it WebAssembly? Is it single threaded? You got the garbage collector, so that's going to be like kind of single thread and that kind of stuff. So what engine are they actually using?
So usually it's WebGL, and there's basically you have a WASM bundle, and that's how everything loads. It's very similar for WebGPU. It's basically just what it uses to render, and it just gives you a bit more access to the GPU. That's a big question, and I don't quite on the top of my head have all of the answers to that. But it's basically new rendering tech for the browser, and all of the major browsers support it now.
Yeah, cool. So the WebGPU stuff then, is that like is that with Godot or Unity or both?
So both of them, and a lot of other engines are supporting it now as well. So Godot introduced experimental support in 4.3, I think it is, and Unity introduced experimental support in Unity 6.1. And broadly by the end of this year, it'll be out of experimental in the game engines, but I've used it in both. It works great. It's experimental by name only, I think, at this point.
Nice. That's nice to hear, actually. And kind of how is it that you use it? Is it special APIs, or is it just the way it compiles things, or what?
In Unity, you just switch the render target. So there's a checkbox, and there's a checkbox currently. It defaults to auto select rendering framework. You deselect that and add WebGPU, and it's a similar process in Godot. I can't quite remember off the top of my head, but it's a similar process there. And then other game engines just use it by default. So Default, I think they just have it enabled by default because it's so it's so prevalent now. It's
I do like a nice simple checkbox. It's got to be said.
Yes. Yeah.
We wish more things were just a nice simple checkbox.
Absolutely, yeah. Have we got any more questions?
Yeah, I have some personal questions. Like, I'm not really familiar with, for example, Unity addressable or Godot resources. I wonder if you can split the process of loading the resource into multiple stages. So, for example, while you are still in the process of loading the main menu, triggers the load, for example, of the last save game. So for the gold path, you have the shortest loading times, and for the game.
Exactly. Yes, that is exactly right. And Unity will cache them. In Godot, you can set something up again, more manual process. But in Unity, it will cache them as well. So if you've downloaded it before, it'll download again really quickly. And yes, broadly, what you're saying is right. You split them into different groups. You can load them whenever you want in the game. So as you're finishing level 1, you might hit a certain hitbox, and it will start loading the next level in, and then by the time you actually reach the end of the level, you can start that level. But oftentimes what I do is only do the initial game download. So that's basically a loading screen, and maybe one shader to animate some dots in the background so it moves around. That's all I put in the main game folder, in the main game binary. And then I'll use addressables to load in the menu and the tutorial, and then you can have a progress bar there for that. And that's just that bit of feedback that the player needs.
Right. So pretty much that answers my question. There we have a question from the audience. So when you separate the assets and compress them for Godot, for example, do you also need to manually decompress them after they have been downloaded, or it's handled by the engine?
So that is handled by the browser, actually. So when you download something in the browser, that will then that'll decompress it if you use Blockly or gzip compression. You need to set the content encoding headers on your server for that to work. But it is just handled automatically. Basically, you download a .br file, and once that is finished downloading, the browser then decompresses it and then gives you the data.
Got it.
So how much of it is handled by the browser, and how much of it is handled by WebAssembly and so on?
So it's actually I'm not 100% familiar with the process, but as I understand it, any download that comes through the browser basically has an extra step at the end, and the browser will decompress the blocky files or gzip compressed files.
Yeah, and so it just uses the normal browser cache and things like that. Yeah, I always think of I always think when you got WebAssembly, it always feels like it's just a completely different world. I never quite realize how well integrated it is actually.
Yeah.
Yeah. Do you have a particular favorite amongst the different engines with Unity,
I have
Godot,
used Unity for so long. Everything Unity is just second nature to me.
Yeah.
I'm building that familiarity with Godot. I like the way they do some things. I don't like the way they do other things, but that's mostly because I am very Unity brained. My recommendation, if you're starting, is Godot, because basically it being open source, it's much easier to get started with. It's a 50 megabyte download last I looked. It runs on any hardware whatsoever, where Unity is sat there downloading a 10 gigabyte engine. So it's lean, it's easy to get started with. GDScript is quite fun to use, and really easy to get started with. So Godot tends to be my recommendation for newer developers, but I'm Unity through and through.
That's quite interesting. Then sort of saying you're Unity through and through, and yet recommending Godot.
Yeah. I think so. There are a few things with Unity that are more complicated than they really need to be. C# is a more difficult language to get started with than GDScript. There are just a few things like that, and I really value for newer developers the ability to just basically download an engine and have it there running straight away. With Unity, it's such a big download that it's quite a barrier, really.
Okay. Yeah. Still quite an investment to get started and get going with Unity.
Yes. But it's still entirely doable, and they've got a lot of really good first-party tutorials.
Yeah. I mean, that's where Unity started, really, wasn't it? The ease of use and getting going.
Yeah.
I think we've got another question here as well. Is there ever a reason not to compress textures and 3D models in order to keep them at a higher quality?
So that is up to you. If you basically, when you're making a game for the web, you'll have an idea about how quickly you want users to get in. You'll have some threshold for, actually, this is now unacceptable and I need to look at the download size. Obviously, as a game developer, you don't want to compress the hell out of things and have it all look a mess, but it is worth it on the web. Generally, I just default to compressing everything as much as I can, and seeing if I can make it look good with those highest settings, those highest compression settings.
That's actually an interesting topic about your expectations and what you are looking for with performance, because I've heard for some of the not game dev related, for example, but I know a story about one massive digital shop that was actually ABA testing, slowing down specifically the web view of their store to figure out when the retention goes for the users, so they know how much of the background do they have the resources to add new features and utilize more resources before they will start to lose the user.
That's a nice idea. Figure out what your budget is.
Yes, exactly. Yeah.
I guess a bit of a follow-on from that actually is what about testing and ensuring that you are kind of fitting in within these boundaries and guidelines that you're after?
So largely my process is build it and see. That can be a long process for some game engines. Unity web builds can take 30 minutes or more. If you enable all of the compression settings and things, it can be up to 90 minutes. I've had it in some builds, but that's the best from my experience. The best way to see how big your build's going to be and how quickly your game runs is to actually just get it built and running.
Is this the kind of... Sorry, Karen.
I was just going to say, you have profilers in both Unity and Godot and in Chrome itself. and you'll be able to see what's kind of taking time. You can profile each individual bit, and when you build in Unity, I'm not sure about Godot, but when you build in Unity, you get a build report, which is like a log file in your projects in your directory. And that log file has, it's called build report. It tells you what's taking up the most room in your build. So if you've got a 30 megabyte texture in your build, then that will flag it at the top and say, hey, what are you doing?
Yeah. But it's still up to you to actually check that build log.
Exactly, yes. So in Unity, you have the project auditor, and at Crazy Games, we have an SDK optimizer, which kind of slots into that. And they will flag things before you've even built it. And they provide buttons to quick fix things. So the tooling is improving. And in Godot, things are I can't really say too much because I'm working on some of it, but things are moving in that direction. So,
well, it's always nice to be able to commit back into the project.
Exactly.
So,
yes.
We're also big fans of inspections and quick fixes. It's it's a good way of working, I think.
Yeah, and I like nice pie charts, and so you can actually visualize what's where and what's taking things up, what's taking space up.
We don't do too well on the pie charts. It's got to be said. At least not in the IDEs. We've got some server side stuff.
Yeah.
Have we had another couple of questions drop in there?
Yes, we actually do. One of the questions is, how the download process is handled in Godot? So for individual packages, should it be done manually or?
Yes. So you basically, Godot will build a PCK file. You upload that to your server. There is some Godot code to basically download that manually. Let me see if I can go back a little further. So I've on the slides. There you go. So you manually download it with the HTTP request API. And then once you've done that, you have to write it to the file system. It's a whole process. Again, this is improving, but for now, this is the way you have to do it.
Well, nice. It gives you the flexibility to do that.
Yes. Yeah. So largely, you can just do everything in Godot, but there are a lot of things that are quite manual.
Yeah. I think we had a bit of a follow-on question in a way as well. So asking, how about vector graphics for textures where possible? Does that help reduce the asset size?
It does, yes. I had a full Unity game without using addressables that was under 10 megabytes because basically all of the graphics were vector graphics. So that is a really good way of doing it. Yeah. So if you have that ability, then yes, vector graphics are great for reducing your build sizes.
What about the disadvantages to that?
It can be more difficult to animate in Unity in particular. The vector graphic importer is not great. It's experimental still, and I don't think they've worked on it for a year or more. So it's you can there are some trade-offs there. I actually use an asset called Shapes by Freya Holmer. It's not true SVGs, but it's a vector graphic library. So there are no textures.
Yeah, I've seen that. There's some pretty impressive results you can get out of that library, actually.
Yes.
That's pretty cool.
Yeah.
Awesome. Alex, do you have any other questions?
I guess the last one from me personally. Back in my day, we had to focus on actually packing the order of the memory layout for loading the game to be able to sequentially load it from the CD or the hard disk. Can you actually specify the memory layout for loading packages for Unity and Godot resources?
That is a very good question. Not to my knowledge, in Godot, I would be surprised if there wasn't a way to do it, but I don't suspect it'll be an easy process. In Unity, beyond just using a bunch of addressable asset groups and kind of loading them in manually, you can then also free things in there. So I don't think so is the answer to your question, but yeah, it's a good question and something that I'd actually be interested in now you've mentioned it.
I mean, it not might be related anyway to our days because everything is SSD now.
Yeah.
I think we've had one last question pop in there as well. Someone's asking, what's your philosophy when it comes to lighting in WebGL or web builds?
Yeah, so lighting, generally you want hard shadows, not soft shadows. You want to bake it because you're really limited in performance on the browser. So you can do it. You have to really be very intentional about where you use it and how your dynamic lighting's working. Now we've got WebGPU. Again, that improves things because a lot of that can be done on the GPU side. So there are improvements there. But typically, like hard shadows, stylized lighting is what's going to work best on web. I don't actually make that many 3D games, but so I'm mostly 2D. But that lighting can be tricky. It's quite intensive. But WebGPU goes some way to fixing it.
All right, cool. Right, I think we're all finished the questions, unless you've got anything, Alex.
No, there was just the last one just popped up. So is there something similar to vector graphics, but for audio to help with the asset size? And I think it will be the last one because we are like a little out of time.
Not to my knowledge. Not to my knowledge. Yeah.
Yeah. There we go. Nice and easy.
Cool.
So no, we're still stuck with the usual audio files then.
Yeah.
Yeah. Okay, well, Dom, thank you very much for a great session there. Again, packed full of some fantastic hints and tips and useful information there. And thank you for your time. And I think we'll say goodbye for now.
Cool. Bye.